There is a moon orbiting Jupiter that shouldn't even exist. It spews lava hundreds of kilometers into the freezing vacuum of space. It melts itself from the inside out, and it does all of this millions of miles away from the warmth of the sun. This is Io. It is a planet-sized volcano with no off switch. It defies every rule of planetary science, and what we have discovered about this nightmare world in recent years might just change everything we think we know about life, energy, and the violence of the universe. Hi there! Welcome back to the channel. Before we dive into this volcanic hellscape, do me a quick favor. If you love exploring the weirdest corners of the cosmos with us, hit that subscribe button and turn on notifications. It really helps us keep these videos coming. Done? Awesome. Now let's take a trip to Jupiter. At first glance, Io looks like something pulled straight from a fever dream. It is a world scarred by fire, a sphere painted in violent yellows, deep reds, and sickly greens. It has eruptions so massive they touch the edge of space, all while orbiting farther from the sun than Mars. By all logic, this moon should be a frozen, dead rock. So how does it burn so brightly? To answer that, we have to abandon everything we thought we knew about moons. Io isn't just a satellite. It is the most tortured body in the solar system. It is a living furnace. Imagine a moon caught in a trap. Io orbits Jupiter about 390 million miles from Earth. It's roughly the same size as our own moon, but that is where the similarities end. While our moon is silent and still, Io is violently alive. It whips around Jupiter in just 1.77 Earth days, but it's not a smooth ride. Io is caught in a gravitational crossfire. It's locked in a delicate, rhythmic dance with two other massive moons, Europa and Ganymede. Here's the mechanics of the madness. For every orbit Ganymede makes, Europa makes 2, and Io races through 4. This gravitational tug-of-war forces Io into an orbit that isn't a perfect circle, it's an oval. As it swings close to Jupiter, gravity squeezes it. As it moves away, it relaxes. It's like taking a rubber stress ball and squeezing it over and over again, thousands of times a week. But Io isn't made of rubber, it's made of rock, and rock, under that kind of immense pressure, does something extraordinary. It melts. This unassuming moon is boiling from within. The friction generated deep inside its core turns solid rock into magma. It creates not just pockets of heat, but vast oceans of molten silicate bubbling just beneath a thin, fragile crust. And when that pressure gets too high, it erupts. But these aren't like the volcanoes we have on Earth. These are monsters. Some plumes shoot lava and gas over 300 kilometers high, escaping the moon's gravity entirely. A single eruption can coat thousands of square kilometers in fresh, glowing rock. The lava here can reach temperatures of 1,300 degrees Celsius, hotter than the hottest lavas on Earth today. And then there are the colors. If you look at Io, it looks like a painter spilled their palette across a canvas. But this isn't art, this is chemistry at war. The dominant yellow hue comes from crystallized sulfur. The reds and oranges, those are the scars of a recent activity where sulfur has been cooked by radiation. And the white patches looking like snow, that is frozen sulfur dioxide frost. When Io slips into Jupiter's shadow, the temperature plummets and the thin atmosphere collapses, falling back to the surface as chemical snow. Then, when the sunlight hits it again, it sublimates, exploding back into gas. But the strangest color of all is green. Scientists have spotted strange green swirls that shouldn't be there. They believe it's sulfur monoxide, a molecule that is unstable and rare on Earth. But on Io, bathed in the intense radiation of Jupiter's magnetic field, it glows. This radiation doesn't just hit the moon, it sculpts it. It blasts the surface, breaking molecules apart and repainting the landscape in ways no other world can match. On Earth, volcanoes are mountains, majestic cones like Fuji or Kilimanjaro. On Io, forget that. This moon doesn't build mountains, it destroys them. The volcanoes here are chaotic pits and sprawling lava lakes. Take Loki Patera, for example. It's a depression as wide as Lake Ontario. It's a literal sea of lava with a crust that periodically shatters and overturns, sinking into the magma below like breaking ice on a winter pond. It is a terrifying, mesmerizing cycle of destruction. However, amid this flat melting landscape, there is one feature that stands defiant. They call it Steeple Mountain. It is a jagged, solitary shard of rock piercing the sky, rising nearly 7 kilometers high. It has no slopes, no volcanic cone. It looks like a dagger pushed up from below. Scientists believe this isn't volcanic, it's tectonic. As the crust of Io collapses and compresses, giant blocks of rock are squeezed upward, creating these monoliths. It is proof that even in a world of liquid fire, solid rock can still fight back. For decades, we thought Io hid a global magma ocean beneath its shell, a single sloshing sea of liquid rock. But recent data from NASA's Juno mission is rewriting that story. Juno's gravity measurements suggest something more complex. Instead of one ocean, Io might be filled with a magma sponge, interconnected pockets of melt scattered throughout a solid matrix. This explains why different volcanoes behave so differently. It's not one system, it's hundreds of independent engines, all firing on their own chaotic schedules. We owe this knowledge to Juno. Since 2016, this spacecraft has risked everything, diving through Jupiter's deadly radiation belts to capture images of Io that are simply breathtaking. It has shown us lava lakes shimmering in infrared. It has captured plumes in action. It has shown us a world that changes not over millions of years, but over days. An eruption here, a collapse there. It is a planet evolving in real time, right before our eyes. Io is chaos, frozen in motion. It is a place where gravity becomes fire. It is a laboratory for the extreme, showing us what the early Earth might have looked like 4 billion years ago. It reminds us that the universe is violent, dynamic, and incredibly beautiful in its destruction. It proves that a world doesn't need to be in the Goldilocks zone to be active. It just needs the right kind of push. It's terrifying to think about standing on that surface watching a wall of lava approach under the giant gaze of Jupiter. But it makes you wonder, if life can exist in the deep oceans of Europa or Enceladus, could something even stranger exist in the energy-rich chaos of Io? Or is it truly just a dead, beautiful hell? I want to know what you think. Could Io harbor some exotic form of chemistry we don't understand? Or is it the most hostile planet in the solar system? Drop your theories in the comments below. I read every single one. Thanks for watching, and keep looking up.